So for the next few videos, we'll be looking at the reciprocal of a quadratic equation. And the first one that we're going to take a look at is example 3, where we're going to consider the function f of x is equal to x squared minus 4. So for the first thing that we're going to look at, we're going to determine what its reciprocal is, figure out what the non-permissible values for x are, state the equations of the vertical asymptote for our reciprocal function, determine what the x-intercept and the y-intercept is of our reciprocal function, and then we're going to graph both functions, f of x equals x squared minus 4, as well as the reciprocal function. Okay, so for the first part of the questions, if f of x is equal to x squared minus 4, then its reciprocal is y equals 1 over x squared minus 4. The reciprocal function is not defined when f of x is equal to 0. Okay? And that's because when f of x is equal to 0, we get our x-intercepts, and the x-intercepts of our original function end up being the non-permissible values for our reciprocal function. Okay, so let's take a look at that. If we take our function f of x is equal to x squared minus 4, and we say y is 0, that means we're looking for our x-intercepts, and we will solve for x. So we're going to get x squared equals 4, and then square root both sides, and we get that x is equal to plus and minus 2. Okay, so that means that our x-intercepts of our quadratic x squared minus 4 are plus and minus 2. Now just remember, if you want, you can also factor the x squared minus 4, because that's a difference of squares, to get your x-intercepts. Okay, and how does that relate to our reciprocal function? Well, our reciprocal function is y equals 1 over x squared minus 4. And recall from when we were looking at rational expressions, the denominator can't be 0, so that means the x squared minus 4 can't be 0. So let's find out where it is 0. And notice it looks the same as looking for the x-intercept of our original function. So we will get the same values for x. Okay, so these are the non-permissible values for 1 over x squared minus 4. Okay, so it happens at x equals 2 and x equals negative 2. So the vertical asymptotes are located at the non-permissible values of x. The equations of the vertical asymptotes are x equals 2 and x equals negative 2. Now let's take a look at x-intercepts and y-intercepts. At the x-intercepts, the coordinate y is 0, right? You know that. When you're looking for x-intercepts, plug in y is 0. So we will go to our reciprocal function, and in place of y we will put 0. Okay, and remember, if we want to eliminate denominators in equations, we just multiply both sides by the denominator that we have, and we get that 0 is equal to 1, but we know that's not true. Okay, and so there are no x-intercepts for our reciprocal function. Okay, so there are no x-intercepts for which y is 0, so there are no x-intercepts. Now at the y-intercepts, the coordinate x is 0, right? When you're looking for y-intercepts, you plug in x is 0. So let's take a look at our reciprocal function again. We're going to plug in 0 for x, and we get that y is equal to negative 1 over 4. So this is our y-intercept. Okay, so now we're going to graph. We will start by graphing f of x is equal to x squared minus 4. It's in vertex form, so we can see that our vertex is at 0 and -4. Now, take note, x is 0. This vertex is also our y-intercept. All right, our x-intercepts for a function, we already worked it out previously, but just to remind you, we put in 0 for y, and we solve for x. So we get that our x-intercepts are at plus and minus 2. Okay, so let's go over to the graph. We will graph that. We have a vertex at 0 and -4. We have x-intercepts at -2 and +2, and we will graph our parabola in. All right, and that is y equals x squared minus 4. So now we will take a look at graphing our reciprocal function. We have vertical asymptotes at x is equal to 2 and x is equal to -2. Those are our x-intercepts of our original function. And we have a horizontal asymptote at y equals 0. Okay, our invariant points, remember they happen when y is equal to 1 and y is equal to -1. So let's plug those in. Remember that invariant points are true for both the original function as well as the reciprocal function, so I'm going to use the original function to find out what our invariant points are. So we get 1 equals x squared minus 4. X squared then is equal to 4. 4 plus 1, which gives us 5. And so x is equal to plus and minus the square root of 5, which gives us two values for x, one at 2.2 and one at -2.2. So our invariant points are at 2.2 and 1 and -2.2. Sorry, -2.2 and 1. Okay, let's plug in where y is -1. So -1 equals x squared minus 4. X squared then is equal to 4 minus 1, which is 3. So x is equal to plus and minus 3. And so we get two values for x, one at 1.7 and one at -1.7. And so we have two invariant points here also, so 1.7 and -1, and 1.7 and -1.7 and -1. Okay, now we're going to take a look at relative mins and max. Now, whether you have a relative minimum, or a relative maximum is going to depend on whether your original function opens up or down. When your original function opens up, you are going to have a relative maximum. When your original function opens down, you're going to have a relative minimum value. Okay, so because our parabola is opening up, we're going to have a relative maximum point. And how do we get that? Well, we take a look at the minimum of our original function, which is at 0 and -4. And for reciprocal functions, to find another point on our reciprocal function, when we already know a point on the original function, all we have to do is take the reciprocal of y. Okay, and so our relative max will be at 0, and we take the reciprocal of -4 and we get -1/4. Okay, so we're going to use this to graph our reciprocal graph. We will start with our invariant points. We will draw vertical asymptotes. Sorry, not our invariant points. We're going to start with the vertical asymptotes, where x is equal to -2 and x is equal to 2. And then our other asymptote is horizontal, and it is at y equals 0. All right, now our invariant points. We have one at 2.2 and 1, which is approximately here, and the other one is at negative 2.2 and positive 1, which is around there. Okay, so this is 2.2 and 1, negative 2.2 and 1. Our other invariant point is when y is negative 1 and x is 1.7, so that's around here. Okay, so 1.7 and negative 1. And the other one is where y is negative 1 and x is, oh, this is negative, positive 1.7. Okay, so you should have 4 invariant points, 2 above the x-axis and 2 below the x-axis. Okay, now we're going to put in our relative maximum, which we know is 0, negative 4, which is approximately here. Negative 1/4, sorry. And the reason why we call it a relative max is because we're going to find that in between our two vertical asymptotes, that will be the highest point. All right, so now we're going to graph in our reciprocal graph. The behavior of our reciprocal graph is opposite the original graph. So if the original function goes up, the reciprocal function goes down, and vice versa. Be sure to make the reciprocal graph glide along your asymptotes. All right, so we're going to start with the part below the x-axis. It's the easiest part. If you take a look at the graph of our original function under the x-axis, it's a parabola that opens up. So we want an opposite behavior to that, which means that we're going to have a parabola that kind of, well, it's not really a parabola, but it looks like one, and it will be opening down. And the difference between our reciprocal function and our original function is that the part that opens down on our reciprocal function has a flatter top. Okay, so you graph it kind of flat, go through the invariant points and glide along your vertical asymptotes. Okay, so kind of flat at the top, glide along your vertical asymptotes. Okay, now for the part that's above the x-axis, we kind of split up into two different parts where our y values are greater than 1. Okay, so let's say we take a look at this point right here where we have what looks like could be, you know, where x looks like it could be like a quarter, but that's not really that important. What's important is that our y value is equal to 2. If we want an opposite behavior, then we want the reciprocal of the 2 to graph a point for our reciprocal function. So if y is 2 right here, then our reciprocal function is going to have a y value which is 1/2, and so it's going to be around here. Okay? And we can even go up a little higher and say that we have a y value which is 4, and then the reciprocal of 4 is a quarter, so we can bring down a point to here and go to where y is about a quarter, which is there. All right, and if you take a look at the part of the graph that's on the left of our invariant point, we've got values for y which are less than 1. So I'm just going to do 1 from there. So let's say we take a look at a point which is where y is equal to 1/2. Well, the reciprocal of 1/2 is 2, so we're going to have a point on the left side of our original function where y is about 2, which is right there. Okay, and so you can see that's what's going to happen to the graph is it will glide along our vertical asymptote, go through our invariant point, and glide along our horizontal axis. And you'll find that the behavior of the graph over on the left is exactly the same. You will go along the vertical asymptote, go through your invariant point, go along your horizontal asymptote, and you will have an arm that looks very similar to the one on the right, except it's a reflection. Okay, so the green graph then is our reciprocal function, y equals 1 over x squared minus 4. Okay, and we will discuss the chart in the next video.